Hey guys, it's Ryan Haley, and my presentation today is on Chapter 8.1, Errors, Failures, and Risks, in the Sarah Bass book. Sarah B book? We'll go with that. Just to give you guys an overview of what the chapter's about. Most computer applications are so complex that it's nearly impossible to produce programs with no errors. Computer glitches and system failures have a myriad of causes, including faulty design, sloppy implementation, careless or insufficiently trained users, and poor interfaces. The chapter brings up a lot of questions that people who create technology, have to ask themselves, like how good is good enough? When should we decide that a computer system is too risky to use? And why do multi-million-dollar systems fail so miserably? It helps understand the problems from few perspectives. First, there's the computer user. Whether we use our own tablet or a sophisticated, specialized system at work, we should understand the limitations of computer systems and the need for proper training and responsible use. There's the computer professional. Understanding the source and consequences of failures is also valuable if you work in the computer world, particularly if you will be responsible for buying, developing, or managing a complex system for a hospital, airport, or business. If it's, outside of those three things, then it doesn't really matter that much. Or you might be an educated member of society. There are many personal decisions and social, legal, and political decisions that depend on our understanding of the risks of computer system failures. Jury members, lobbyists, deciding whether or not to have surgery performed by a robot, deciding whether or not to become part robot. These are all things where these questions come into play. We can categorize computers and errors and failures in several different ways: the cause, the seriousness of the effects, and the application area. Just to go over some problems for individuals, can happen to people like me and you. Billing errors are a common but easy to fix problem. Big mistakes are obvious and usually get fixed pretty quickly. It's the smaller ones that typically go unnoticed. Then the book has a ton of examples of how all of this stuff can go wrong, or a time where it did go wrong. For example, a water utility company sent a customer an incorrect bill for $22,000. A spokesman for the company pointed out that one incorrect bill out of 275,000 monthly bills is pretty good. It is better than a 99.999% accuracy rate. Is that reasonable? At some point, the expense of improving a system is not worth the gain. You can have inaccurate and misinterpreted data in databases. It is difficult to get accurate and meaningful error rates from major databases with information about millions of people. Also, we need to distinguish between a spelling error in someone's address and an incorrect report that someone bounced several checks. The results of numerous surveys and studies vary considerably, but they indicate that a high percentage of credit records have serious errors. Also, databases like the sex crime list are filled with errors that regularly condemn innocent people. Errors in databases used by law enforcement agencies can lead to arrests at gunpoint, strip searches, and time in jail with violent criminals. For example, 2 adults went to jail for 24 hours while police determined that the car they had been accused of stealing was actually a rental. And police arrested a man in Michigan whose identity was stolen by a man who had murdered people under his name. The man was arrested 5 times before the error was fixed in the system. So basically this chapter could be called People Mess Up All the Time, not computers. Several factors contribute to the frequency and severity of the problems people suffer because of the errors in databases and misinterpretation of their contents, such as a large population, automated processing without human common sense or the power to recognize special cases, overconfidence in the accuracy of data stored on computers, errors in data entry, failure to update information and correct errors, and lack of accountability for errors. The lessons of adequate planning and testing, of having backup plans in case of failures, and of honesty in dealing with errors apply to large projects and other professions as well. A 3-line change in a 2 million line telecommunications switching program caused a failure of telephone networks in several major cities, thanks to AT&T. A computer malfunction froze the London Stock Exchange for almost 8 hours on the last day of the tax year, affecting many people's tax bills. There can be failures in voting systems. There were many non-computer related issues regarding voting in the 2000 presidential election. Vote counters found the ballots difficult to read. Recounting was a slow, tedious process. And of course, old people mess things up because they are old. In 2002, Congress passed the Help America Vote Act, moving to electronic voting. This just led to different problems. Some electronic voting systems just crashed. A program error in Texas generated 100,000 votes for one candidate. I wonder which one. And old people continue to be old, continue to mess things up. This can happen in airports, like airports in Denver, Hong Kong, and Malaysia. Here's some problems at the Denver airport. You can have real-world problems. Some scanners got dirty or knocked out of alignment and could not detect carts going by. Faulty latches caused luggage to fall onto the tracks. You can have problems in the systems. The airport's electrical system cannot handle the power surges associated with the new baggage system that they created. You can have software errors. A software error caused the routing of carts to waiting pens where they were actually needed. Possible reasons for the failures. The time allowed for development and testing of the system was insufficient. The only other baggage system of comparable size was at Frankfurt Airport in Germany. The company that built the system spent 6 years on development and 2 years testing and debugging. BAE Automated Systems, the company that built the Denver system, was asked to do it in 2 years. Some reports indicate that because of the electrical problems at the airport, there were only 6 weeks for testing. Or, Denver made significant changes in specifications after the project began. Originally, the automated system was to serve United Airlines, but Denver officials decided to expand it to include the entire airport, making the system 14 times as large as the automated baggage system BAE had installed for United at San Francisco International Airport. Either way, these system failures were due to poor human decisions. There's a lot of abandoned systems where the flaws in some systems are so extreme that the systems end up in the trash after wasting billions of dollars. There's a lot of reasons why these abandoned systems fail. It could be lack of clear, well-thought-out goals and specifications, poor management and poor communication among customers, designers, programmers, and so on, institutional or political pressures that encourage unrealistically low bids, unrealistically low budget requests, and underestimates of time requirements. It could be use of very new technology with unknown reliability and problems, perhaps for which software developers have insufficient experience and expertise, or a refusal to recognize or admit that a project is in trouble. Either way, anyway, human failure. So what goes wrong? Computer systems fail for 2 reasons. The job they are doing is inherently difficult, and sometimes the job is done poorly. Some of the factors in computer system errors and failures include design and development, which means inadequate attention to potential safety risks, interaction with physical devices that do not work as expected, incompatibility of software and hardware, or of application software in the operating system, not planning and designing for unexpected inputs and circumstances, confusing user interfaces, insufficient testing, reuse of software from another system without adequate checking, overconfidence in software, carelessness. It could be the management and use, like data entry errors, inadequate training of users, errors in interpreting results or output, errors in reading that last sentence, failure to keep information in databases up to date, overconfidence in software by users, insufficient planning for failures, no backup systems or procedures. It could be misrepresentation, hiding problems, inadequate response to reported problems, insufficient market or legal incentives to do a better job, and it looks like that is all. So basically, the whole chapter is about how people are the worst because all we do is mess up and we always have the ability to blame technology. Peace out, people.